Welcome to my channel Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, today we are starting a very exciting and a very important chapter, which is the periodic tables and periodicity of properties. My dear student, uh, before we dive in, let me ask you something. Have you ever looked at the periodic table in your classroom and wondered why are these elements arranged in such a special order? Why do elements in the same columns behave alike? And how did scientists even figure this out? For this student, have these questions ever popped in your mind? Stay with me because in this chapters you will get all the answers. Now, why we need a periodic table? My dear student, long ago, scientists discovered only a few elements like gold, silver, and copper. But as time passed, more and more elements were discovered. Imagine you're a student back then. You have to study dozens of elements, each with different properties, and no system to rise them. Sounds confusing, right? But it's real. That's why scientists started thinking, can we arrange elements in such a way that similar elements come together? Can we predict the behavior of new elements from this arrangement? And deep thinking led to the creation of the periodic table. Now, what is a periodic table? My dear student, a periodic table is a systematic arrangement of elements in rows and columns based on their atomic numbers and properties. My dear student, let's look at the structure. The horizontal rows are called periods, vertical columns are called groups or families. My dear student, elements in the same groups show similar chemical properties because they have the same number of valence electrons. And elements in the same period show a gradual change in properties as you go from left to right. Now, my dear student, journey to the modern periodic tables. Now listen carefully. The periodic table we use today didn't just appear overnight. It was built step by step. And the first one is Dobereiner's triads, which is grouping elements and trees. Dobereiner grouping elements and trees. What is student? This is a Dobereiner triads, which are grouping elements and trees. Now, and the second one is Newton's law of actives. It's finding patterns every eighth element. You see, this is a Newton's law of actives, in which patterns every eight elements. Now, the third one is Mendeleev's table. It's arranging elements by atomic masses and leaving gaps for unknown elements. This is a Mendeleev's table, you see. Now, the fourth one is Moseley's Modron's law. It's arranging by atomic number, which give us today modern tables, you see. So, my dear student, periodicity of properties. What is periodicity of properties? My dear student, when elements are arranged in order of increasing atomic numbers, their physical and chemical properties repeat at regular intervals. This repetition is called periodicity of properties. This repetition is called periodicity of properties. For example, lithium, sodium, and potassium are all in the same group. They are all soft metal that react vigorously with water. And fluorine, chlorine, and bromine are all halogens with similar reactivity. Why? Because elements in the same group have the same outer electron configuration. Now, why is the periodic table so important? Are you studying? Because it gives us all the elements in one chart at help us predict properties of unknown elements at show trains like atomic size, metallic and non-metallic characters, metallic and non-metallic characters, ionization energy, and so on. My dear student, that's why chemists call it the heart of chemistry. My dear student, this is all about today's lecture with the equations of the periodic table and periodicity of properties. My dear student, if this lecture helped you, then don't forget to like the video and subscribe to the channel for more chemistry lectures and share it to the friends and comment your questions below. Thank you for listening.